Okay, so our next presentation is actually going to be remote. And this is a streaming session-based recommendation. And we'll be hearing from Sarah Latifi.
Hello, everyone. Welcome to this talk about the performance comparison of recent graph neural networks and the nearest neighbor method for streaming session-based recommendation. I'm Sarah Latifi, and this research has been done in collaboration with Dietmar. In the beginning, I want to clarify the messages of our research. We do not claim that graph neural networks does not work for streaming-based recommendations, or deep learning does not work for recommender systems or in general, or we shouldn't use them for recommender systems, or we should only use nearest neighbor techniques for recommendations. But our observations show that nearest neighbor techniques often have surprisingly good performance, and it is important to properly select and tune baselines to ensure the progress in the field. Session-based recommendation is a subclass of sequence-level recommendation, and it is highly relevant in practice. The goal is to recommend items that are that match the short-term interests of a user in an ongoing session. Here, the common assumption is that the models are periodically retrained to accommodate newly collected data. However, there are some different domains, like news, where it is desirable to update the underlying model frequently. In a streaming session-based recommendation, there is a need for frequent model updates, and the often computationally high costs of full retraining complex models led to the design of a streaming session-based recommendation algorithms. These algorithms process a constant stream of new usage sessions to incorporate into the model without full retraining. They are related to the class of models that support online machine learning and incremental updates. A streaming session-based recommendation is not a new problem. For example, a framework for benchmarking a stream-based news recommenders from 2018 implements a number of algorithms, including 2 nearest neighbor methods that can immediately incorporate new events into their predictions. Recently, 2 streaming session-based models are proposed in KDD 2019 and SIGIR 2020, where both models are a reserve-based use a reserve-based technique and an active sampling strategy. Here's some background for the motivation of our current work. There are a number of recent works that indicate that progress in our field can be limited, and the most recent deep learning models are often not better than the conceptually simpler methods. Also, our recent work shows the same phenomenon. This is not limited to recommender systems research, but also other domains, and multiple issues can contribute to the lack of progress, including choice of baselines and lack of proper tuning of baselines. In this work, we examine if this phenomenon also exists for a streaming session-based recommendation or not. With this aim, we inspect the recent existing work in this field. In one case, the authors were unable to recover the code of their model. In another case, the authors didn't share the code with us. And finally, for the GAG model, the code was publicly shared. So we use this model as a representative baseline model in our experiments. We exactly reproduced the experimental setting described in the original paper of the GAG. We use the same data sets and data splits, and actually we use the pre-processed versions of Last.fm dataset and Govala dataset as shared by the authors of the GAG with us. Govala dataset contains check-in information from a location-based social network, and Last.fm contains information about music listening sessions. We also use the same metrics that are hit ratio and the mean reciprocal rank, and note that the recall metric used in the original paper of the GAG model is equivalent to the hit rate when there is only one positive item in for each measurement. Finally, we use the identical evaluation protocol to evaluate the model's performance for a test session We incrementally reveal one item after the other and let the model make a prediction for the next item to be recommended. This figure shows the overview of the use evaluation protocol. The dataset is first divided into two parts in chronological order. The first 60% part is used to initially train the model, and the second 40% part is called candidate set that used to simulate the streaming setting. The candidate set is further divided into 5 blocks of the same time, and the division is by the time. At each step, the model is updated without full retraining based on the new information added to the training data. Overall, this gives us 4 update and evaluate steps. We use the code provided by the authors of GAG and set the hyperparameters values according to the information in the paper and also in the shared source code. This is appropriate as we use the exact same code, same data, and same protocol from their experiments. By this, we could reproduce the results on the Govala dataset. However, for the last event dataset, we couldn't, and actually the results we reproduced was lower than the reported one in the paper. Then we were in exchange with the authors of GAG, but they couldn't recover the the hyperparameter set that led to the results and that are reported in the paper. So we tuned the hyperparameters further on the last FM dataset manually, for example, by reducing the learning rate until we observed hit rate values that were similar to those in the original paper. We observed that reducing the learning rate also helped to improve the results on the Govala dataset. We therefore report both outcomes. GAG shows the results when using the original provided hyperparameters, and GAG-star shows the results when using the set that led to further improvements in our experiments. We benchmarked the GAG model against VSKNN, an effective session-based nearest neighbor method from the literature, as the nearest neighbor methods performed very well in a number of recent works. VSKNN finds past sessions that contain interactions with the same items of the current session, and then items appeared in the neighboring sessions will be considered as candidates for recommendation, where the specific similarity function of VSKNN puts more emphasis on more recent interactions. We also tested its hybrid with SR, a session-based method based on association rules, and SR actually counts items co-occurrences in the past sessions and considers the orders and distance of items when scoring them for recommendation. The hybrid combination returns the first n items from the recommendation list of SR, and then append items from the recommendation list of VSKNN without duplicates to generate the final recommendation list. The combination is motivated by the fact that the recommendations by SR often led to good MRR results. Both VSKNN and SR methods were later extended to consider the past sessions of individual users by incorporating few heuristics. In this work, we denoted these session ever versions as VSKNN Plus and SR Plus and adapted them for to support online updates. To tune their hyperparameters, we used a random search with 100 iterations on the same validation set as for the GAG model. This table shows the results of our experiments where GAG is consistently outperformed by simpler methods, and the relative gains are between 5 to 13% over GAG-star. For the Govala dataset, VSKNN Plus could outperform it on the GAG on hit rate. SR Plus outperforms it on the MRR, and the hybrid combination outperforms GAG on both measures. For the last FM dataset, VSKNN Plus already outperformed on the GAG model on both measures, so there was no need for the hybrid combination in this case. Actually, this paper continues a series of earlier studies which indicate that the progress we achieve with complex models is often smaller than we would assume. One possible reason is that researchers sometimes tend to consider the latest neural models as their main baselines and do not run simpler methods first to gauge the effectiveness of their models. Also, reproducibility of published research seems to be an open issue here. It is not a standard practice for authors to share their code and data. However, the authors of GAG are a positive exception here. And finally, a methodological question in this area is that the choice of the evaluation-based data sets often is not very well motivated. In our view, a typical use case for our streaming-based sessions are news recommender systems or certain e-commerce applications. Thank you very much for your attention.
All right. I don't know if it's my app or if there aren't any questions in the in Slido. I guess one question here is, you were talking about how it's not clear why different applications might need session-aware applications, but it does seem like in a lot of cases, the ability to stream new information as the user clicks things in the interface or takes actions, like that seems to be, the updatability seems to be an important property, and it's something where, a nearest neighbor model has, it's easy to incorporate new items. So I just wonder if you could comment on the streaming piece as opposed to the session-aware piece of this algorithm and results.
Sorry, I didn't get the question.
Okay. So you're talking about a session-based recommender, but you're also trying to incorporate this idea that there's streaming happening. So you want to be able to, to update incrementally.
Yeah.
Right. And so I'm just wondering if you could comment on those two as sort of separate challenges. Like, is KNN particularly useful because of the streaming aspect and the ability to update incrementally with new items? Is that part of the advantage that you're seeing?
Actually, if I understand you correctly, in the previous works, it has been shown that KNN methods perform very well in session-based recommendation and also in session-aware recommendation. And here we just wanted to also check their performance in comparison with recent neural networks for a streaming session-based recommendation. However, I have to say that session-based here is not exactly session-based. It is session-aware version, actually, because not only our method, which is KNN, considers previous sessions of the users, but also the recent neural models also considers the previous sessions of the users. And
Right.
for the KNN, actually update, it's possible, of course, you can update the model simply, actually,
Right.
and frequently, yeah.
Did you examine the influence of session length, the length of the session? I should take this off. What difference that had on the different models?
No, we didn't. And actually, we used the pre-processed versions of the data set as provided by the GAG model, and because right now I don't remember if they had any, but of course they have to, because for last FM dataset at least there can be a very, very long sessions. yeah, there were some limitations for the length of the session, but we didn't examine the effect of the length of the sessions here.
You know, I guess one of the things that your work points out is just the difficulty of conducting reproducible research, and it's some authors are doing more to make that possible than others. Do you have advice maybe for the folks here in terms of what they can do to make their work more reproducible, make it easier for us to be able to do these studies and do these comparisons?
So if you mean that how
are there best practices that you can think of for making reproducibility easier?
Mm-hmm. Okay, so I have to say that one point is about the details. Okay, so in many papers you cannot find enough details if you really want to reproduce the results. For example, the optimal values of hyperparameters. So for example, for the GAG model, we could reproduce the results on the global dataset. However, we couldn't reproduce them for the last FM datasets. So for this, we had to manually tune the hyperparameters to get almost the same results for the last FM dataset. So, of course, the details are important in the paper. They must be mentioned. And the other thing is the pre-processed versions of the datasets, because, always there are some tiny details that authors do not mention in the paper. So if they can also provide the pre-processed versions of the dataset along with their code, so it will be most probable to really reproduce their results. Also, sometimes, the implementation also of the evaluation can be also important, right? Because sometimes, yeah.
I'm afraid we're out of time, so please post any additional questions here on Slido, and those will be answered offline. We got to keep moving in this session.
Sure.
And we have another. Thank you. Let's thank our speaker again.